Hey team, I'm Maddie, welcome to Science Side Up, and today we're talking about adiabatic processes. What in the world does adiabatic mean? Well, imagine that you have a magic balloon and you want to change the temperature of the gas inside the balloon. You're probably thinking to yourself, you put it out in the sun, Maddie. You let it heat up. If you want to cool it down, put it in your freezer. This is not hard. And you're totally right, but those are both examples of diabatic processes. A diabatic process is anything that is going to change the temperature of a system by either adding or removing heat from that system. So if that's what a diabatic process is, then an adiabatic, usually pronounced adiabatic, an adiabatic process is one that's going to change the temperature of our system without adding or removing heat. Well, how in the world does that work? Great question, but we've actually already seen this type of process. I think last video when we did ideal gas law. Imagine that we let our balloon go. Little Timmy here is sad. As the balloon rises, the pressure exerted on the balloon is going to decrease. Fun Navy fact, in the Navy, you're not actually supposed to say increasing or decreasing. You're supposed to say goes up or goes down. Because increasing and decreasing sound too close to each other, that if you're on an old sound-powered phone, then you might get them mixed up. So you're always supposed to say goes up, goes down when you're, for proper phone talking procedures. Believe it or not, every word in that sentence was correct. So we're gonna have to see density and temperature go down as well in order to keep our equation balanced. So density is gonna go down. Now, assuming that we tied our knot really tight and no air is leaking out of the balloon, that change in density will look like an increase in volume. So we get a big balloon. And then we'll also see temperature go down, and that's what we're interested in here. So this drop in temperature was caused by an adiabatic process. The dark science magic of being able to change temperature without actually doing anything to the heat energy of the system. We actually usually think about adiabatic processes so that we can eliminate them. Adiabatic processes don't drive the weather generally. They don't drive storms. So if I'm interested in something like how does the temperature change in the atmosphere leading up to the storm X over here matter for the storm's development, something like that, then what I would want to do is look at the change of temperature and first remove or subtract out all of the adiabatic changes in temperature so that all I'm left with are the diabatic changes. The diabatic changes are generally the interesting, complex bits, so it helps to remove the adiabatic processes first, or to think about those as separate things. Moving forward, we're going to talk a lot about adiabatic and diabatic processes, and now, good job you know the difference. Okay team, that's all I've got for you today. I hope you liked this video, and I will see you all in the next one. Bye team!